In this video, we discuss statistical decision analysis. Suppose you must make a decision and are given several different alternative solutions to your problem. How would you determine which of those alternative solutions to select? In this video, we're going to talk about how you would use statistical decision analysis to lay out and analyze all the different possible solution alternatives and the consequences associated with each of those alternatives, and use the results of this analysis to reach the best possible decision. We're going to start off by looking at what the different elements of decision making are. Then we're going to define a payoff table. Then we'll calculate two different probabilities associated with each of the different alternatives, expected monetary value and expected opportunity loss. Then we'll move on to three strategies that are not probability related: maxi-min, maxi-max, and mini-max regret strategies. Then we'll talk about the expected value of perfect information, and what we mean by that is what we would be willing to pay to have all the needed information ahead of time. And finally, we'll finish with decision trees. So the three elements of a decision are the set of all possible alternatives or choices, the different states of nature under which you have no control. Examples of this might be the weather or the economy, and finally the payoff. And for each different combination of alternative and state of nature, you must have an associated payoff. The difference between statistical decision theory and classical statistics is that in classical statistics, which we've already looked at, we talked about estimating parameters or doing hypothesis testing. In statistical decision theory, what we want to do is choose from among a set of all possible decisions the best or optimal decision. Okay, what exactly is a payoff table? So a payoff table is a listing of all of the payoffs for every possible combination of decision alternative and state of nature. The expected payoff or expected monetary value is the expected value for each decision. So for each of the alternatives or each of the possible decisions you have, you should be able to calculate an expected payoff or expected monetary value. So there'll be one of those for each different alternative. Let's look at how we calculate this expected payoff or expected monetary value. We simply look at each alternative and look at the probability that each state of nature will occur and take the payoff associated with that combination of state of nature and alternative, multiply the probability times the payoff, and do that for each state of nature, add those up, and you end up with the sum equaling the expected monetary value. Now that may look daunting, or I don't know whether you think this is a difficult looking expression or not, but it's pretty straightforward, and we're going to take a look at that in just a minute. I'm going to show you an example in just a minute. So let's move on to an example now. We have Bob Hill here, who has $1,100 that he wishes to invest, and he can choose to invest it in three different possible investment opportunities: Kaiser Chemicals, RIM Homes, or Texas Electronics. He also knows how much money he'll recover if he invests in each of those three different opportunities based on what the state of nature is. And in this case, we have two different states of nature. We have a market rise or a market decline, also known as a bull market or a bear market. We also know, at least we have history that shows us, that the probability of a market rise is 60% and the probability of a market decline is 40%. So here we have the payoff matrix, or the payoff table, and we can see that if we invest in Kaiser Chemicals, that if we have a market rise, we will make $2,400. If the market happens to decline, however, we would lose $100 and only end up with $1,000. And in a similar fashion, we have the information for the other two investments. So let's look at how we would calculate the expected payoff or expected monetary value for each of those different alternatives. Let's look first at Kaiser Chemicals, where we understand that the probability of a market rise is 60% and the probability of a market decline is 40%. So what we're going to do there is we're going to take the 60% and multiply it by the payoff for a market rise and add that to the product of 40% times the payoff, given that we have a market decline, and we ended up with an expected payoff or an expected monetary value of $1,840. Now understand that if Bob invests in Kaiser Chemicals, he's never going to get $1,840. He's either going to get $2,400 or $1,000, depending on whether we have a market rise or a market decline. The $1,840 is nothing more than an expected value based on probability. In a similar fashion, we can calculate the expected monetary value for the other two alternatives. So how would we know which of those to choose? Well, obviously we want to choose the one that gives us the best or highest expected payoff, and that would be $1,840, and the alternative selected would be Kaiser Chemicals. So if we use expected monetary value as our criteria for making a decision or choosing an alternative, we would select Kaiser Chemicals, and our expected return would be $1,840. Okay, let's look at that same data on an Excel spreadsheet. So I'm going to show you these calculations here, how we would do it on the Excel spreadsheet. So let's calculate the expected monetary value. And in order to do that, I'm going to use sum product. And I'm going to take the sum product of the probabilities, and I'm going to make that an absolute reference. And I'm going to multiply that by the payoff for each of the different alternatives, and that would need to be a relative reference. I'll hit return and I'll get my 1840. I can then copy this formula to the next two alternatives, and if I'd like, I might want to format this so that we have it in the same format as the payoff table. But in any event, our selection would be Kaiser Chemicals, and with an expected return of $1,840. Okay, now let's look at the second of those probability-based calculations that we talked about earlier. Let's look at opportunity loss. Opportunity loss, or also known as regret, is the loss because the exact state of nature is not known at the time a decision is made. What that really means is we want to know, if we had known the state of nature, how much did we lose by making the choice that we made. Expected opportunity loss is calculated as follows. The expected opportunity loss is calculated in much the same way as the expected monetary value was, except that rather than use the payoff for every possible combination of alternative and state of nature, we use the regret. And we're going to take a look at how that's done here in just a second. So back to our example, we have the payoff matrix or the payoff table here. What we would like to do is calculate the opportunity loss. Now, how did we do that? How did we get these values here? Well, what we did was we said, if we have a bull market, what's the maximum we can earn? And that would be 2,400. So if we have a bull market and we choose Kaiser Chemicals as our alternative, our opportunity loss would be 0. However, if there's a bull market and we had selected to invest in RIM Homes, we would have lost the opportunity to make $200. And in a similar fashion for Texas Electronics, we would have lost the opportunity to make $500. So that's simply 2,400 minus 2,200 and 2,400 minus 1,900. Likewise, we can also determine the expected or the opportunity loss given a bear market, and we get these different values. Now, to calculate the expected opportunity loss, we want to, exactly the same way we did the payoff table in calculating the expected monetary value, we're now going to do exactly the same thing. Take the probability associated with each of those different combinations of regret and alternative, multiply it by the probability, and get an expected opportunity loss for each alternative. So let's look first at Kaiser Chemicals, and we can see that 0.6 times 0 plus 0.4 times 150 is equal to $60, and we can get the expected opportunity loss for each of the other alternatives by doing the same calculation. So if we look at the three expected opportunity losses, the one with the least expected opportunity loss is Kaiser Chemicals, so that would be our choice based on using the criteria of expected opportunity loss. It needs to be noted that expected monetary value and expected opportunity loss always lead to exactly the same decision. Now we're going to move back to our spreadsheet, and we're going to actually create that table here on Excel, the opportunity loss table. So what I'm going to do is I'm going to use the max function, and I'm going to take equals max, and I'm going to take the maximum of these values, and I'm going to use absolute reference, but I only want the rows to be absolute. I don't want the columns to be absolute, so I'm going to toggle on F4 until only the rows are absolute, the 4, 5, and 6, but the columns are not. I'll close that parentheses, and then I'll subtract the 2400 from it, and that gives me an opportunity loss of 0. I can now copy that formula down and across. So I only had to enter one formula to do all of that. But notice that I used only a part of an absolute reference, not the entire absolute reference. I only made the rows absolute, not the columns. To now determine the expected opportunity loss for each alternative, we'll use sum product. And we will use the probability and make that an absolute reference. Then we will multiply by the opportunity loss, close the parentheses, and we get the expected opportunity loss. We continue that calculation based on the other two alternatives. Maybe I should really copy these down here so we can see this, so we can see what we're looking at. So let's also put in here opportunity loss. And also let's just format these so they look the same as the others. And we see again that we would choose the Kaiser Chemical alternative as the best alternative based on the expected opportunity loss. Okay, so we just finished talking about expected monetary value and expected opportunity loss, and we saw that based on both of those calculations, which are probability-based calculations, we would have selected the alternative of Kaiser Chemicals to be our best option or best decision. We're now going to look at three strategies that do not require probability. The maxi-min strategy, which maximizes the minimum gain. That's a pessimistic strategy. The maxi-max strategy, which maximizes the maximum gain. That's optimistic. And then the final one is the mini-max regret, which minimizes the maximum regret. Another pessimistic strategy. So let's go back again and look at our payoff matrix. And we have the opportunity loss matrix as well. We've seen both of those already. So what we're doing in Maxi-Min is we are asking ourselves, what's the worst case right here? If we choose Kaiser Chemicals, what's the worst case? What's the minimum we would make? And that's $1,000, $1,100, and $1,050. If, however, we elected to look at to be more optimistic and ask ourselves what's the best we can make, we can see that that would be in the occurrences the best we could make would be if we had a bull market. So we have those values. And finally, let's look at what would happen if we looked at the regret matrix, and we can see that if we wanted to minimize the maximum regret, if we chose Kaiser Chemicals, the maximum regret would be $150. If we chose RIM Homes, it would be $200, and if we chose Texas Electronics, it would be $500. So, based on those three strategies, if we elected to use the Maxi-Min strategy, our alternative selected would be Texas Electronics. If, however, we used the Maxi-Max, we would choose Kaiser Chemicals, and if we used Mini-Max Regret, we would choose Kaiser Chemicals with a regret of $150. Okay, we're back to the Excel spreadsheet, and we're going to follow through with the three different strategies that we just discussed. Let's first look at the Maxi-Min. Then we'll look at Maxi-Max. And then we'll look at let's do that. Minimize the maximum regret. Okay, so here we want to calculate the minimum for each of these cases here, each of the payoffs. Under Maxi-Max, we want to calculate the maximum payoff. And we will copy that formula down. Notice we use relative references. And then under Min-Max Regret, I've got to take this out here. I'm going to delete that. Min-Max, let me just go ahead and put that up here. What we want to do is find the maximum value there. And so, what would our decision be under those three different strategies? So in the first case, we want to maximize the minimum, and that would be to choose Texas Electronics. So we will do that. In the second case, if we want to get the maximum, the optimistic criteria here, we would choose the 2400, and down here, if we want to minimize the maximum regret, the minimum of the maximum regrets would be 150. So under Maxi-Min, we choose Texas Electronics. Under Maxi-Max, we choose Kaiser Chemicals, and under minimize the maximum regret, we choose Kaiser Chemicals. So we've seen to date 5 different criteria that we might use in making a decision as to which of the alternatives we might select, and that depends on on which of these criteria you would choose to use. Okay, now let's move on to the expected value of perfect information. What's it worth to know in advance before a strategy employed what the state of nature might be? That's called the expected value of perfect information. It's the difference between the expected payoff if the state of nature is known with certainty and the optimal decision under the conditions of uncertainty. So this is how it's calculated. We just calculate those two expected values, the expected value under conditions of certainty minus the expected value under conditions of uncertainty. So if you remember the payoff matrix, if we knew for sure that the market was going to rise, we would have selected Kaiser Chemicals and the payoff would have been $2,400. If we knew for sure that the market were going to decline, we would have chosen Texas Electronics with the payoff of $1,150. Given the probabilities of each of those states of nature, we can now calculate the expected value under conditions of certainty, and that turns out to be $1,900. If you recall, we previously have computed the expected value under uncertainty, and that value, didn't mean to do that. That value turned out to be $1,840. So if we take the expected value determined under certainty, which we just looked at a minute ago, the $1,900, and we take the expected value of imperfect information under uncertainty, we get $1,840. So the expected value of perfect information is $60. In other words, I'd be willing to pay $60 if I could buy perfect information, if I were able to determine the exact state of nature. Let's now consider one more tool available to us in decision analysis. That tool is a decision tree, and all a decision tree is a picture or a graphical representation of all the possible alternatives or courses of action that are available to the decision maker, all the possible events or states of nature that may occur, and then the subsequent possible outcomes associated with each combination of alternative and state of nature. In a decision tree, we use a box to indicate a point where the decision maker must reach a decision, and we use a circle to indicate that we have an event or state of nature. Here's an example of the decision tree based on the investment problem we looked at earlier. Note we have only one decision point. We have three choices or alternatives. For each of those alternatives, we have two states of nature or events, and for each combination of alternative and state of nature, we have an outcome or payoff. Let's look at an example. We have a property owner that would like to think about possibly building a quickie lube on the property. The property owner knows that there are two possible events or states of nature that could occur should the property be used for a quickie lube, and the first event or outcome is that the results will be favorable, and there's a 48% chance of that occurring, and if the results are good, the property owner will make $100,000. There's also a 52% chance that the results will not be good, and in that event, the property owner loses $50,000. Now, the property owner does have the option of paying $5,000 for a market report, and if the property owner chooses to pay for that market report, there's a 60% chance that the report will come back with a favorable outcome or a prediction of a favorable outcome, and there's a 40% chance that the report would indicate an unfavorable outcome. If the report indicates a favorable outcome, now the chances of having a good year increase from 48% to 60%, while the possibility of a bad year goes from 52% to 40%. If, however, the report comes back with an unfavorable recommendation, and there's a 40% chance that that will happen, the chances of a good year are reduced to 30%, and the chances of a bad year increase to 70%. So let's go take a look at what that decision tree might look like. Here we have a picture of that tree. Let's talk about where all this stuff comes from. Remember that a box indicates a decision point. So the very first decision that the property owner must make is whether or not to buy the report. If the property owner chooses to buy the report, we have an event or a state of nature, and that event is that the report will either come back favorable or unfavorable. In either one of those situations, the property owner must make the decision to either build or not build. If the decision is to build, then we have another event or state of nature, and that would be whether or not the results are good or poor, whether the property owner would have a good year or a bad year. So we have two different decisions that the property owner must make, either buy the report or don't buy the report, and then the property owner must decide based on that information whether or not to build or not to build. So let's take a look at some of these numbers over here. So where does this 95,000 come from? Where did we get that number? Well, if we buy the report is favorable, and we build, and the results are good, we'll make $100,000. We paid $5,000 for the market report, so we realize a profit of $95,000. However, if we choose to build and the results are unfavorable, we lose $50,000 in addition to the $5,000 that we paid for the market report, so we lose $55,000. If we pay for the report and decide not to build, then we just lose the $5,000 that we paid for the report. We get these other numbers in a similar fashion. The only reason this is 100 rather than 95 is because we didn't buy the report, so we didn't have to pay the $5,000 for the report. Let's talk about where this $35,000 comes from. If we build, there's a 60% chance of a favorable outcome and a 40% chance of an unfavorable outcome. So 60% of 95,000 plus 40% of a negative 55,000 yields a net result of a positive 35,000. Now, how did the property owner arrive at the decision here? Well, the choice is to either build and have an expected result of a positive 35,000, given that you got a favorable report, or to not build and lose 5,000. Obviously, the property owner is going to elect to build and hope to make 35,000. In a similar fashion, we get the numbers down here. This 95 and minus 55 are the same as we discussed up here. But if we get an unfavorable report and we build, then there's only a 30% chance of a good result and a 70% chance of a bad result. So 30% of 95 plus 70% of minus 55 gives us a net loss of minus 10. So if we get an unfavorable result or an unfavorable report and elect to build, we can expect to lose 10,000. If we get an unfavorable report and don't build, we would only have the $5,000 that we paid for the report. So given the choice between losing 10,000 or 5,000, I choose to lose 5,000. Where does the 19,000 come from? Well, that's the 0.6 times 35 plus 0.4 times minus 5. So that's the 19,000. We can work our way back out of this one in the same fashion. And finally, we get to this decision point here, where the decision maker must choose between getting the report and having an expected profit of 19,000 or not buying the report with an expected profit of 22,000. So the obvious choice is to skip the report and build, and we expect if we make that choice that we will end up with a profit of $22,000, or that's the expected profit. So that's the most logical and reasonable choice to make. So that's an example of what a decision tree might look like, how you might build it, and how you would walk through it to reach your decision. In this module, we talked about decision making, payoff tables, monetary values, and opportunity loss, some strategies that were not associated with probability, the expected value of perfect information, and then we just finished talking about decision trees.